Hello class. In this video we're going to review how to compare ratios. Now before we actually get into the video we should probably review what a ratio is. Now if you remember from class, a ratio is just a way to compare two different values. And you can do this in three different written ways. So for example, if I was comparing the values 7 and 4, I could write this as 7 colon 4. The second way I could write this ratio is using the phrase 2, so 7 to 4, or I could also use a fraction, 7 over 4. Now for the remainder of this video we're going to be focusing on the colon method of writing ratios. Now you can write these any way you want. You can keep it as the phrase 2 or a fraction, but just know for the majority of this video I will be using the colon. Now, our first example of comparing ratios is comparing two different mixes of iced tea. Now, you can see that mix A has 2 teaspoons of flavor with 3 cups of water, and mix B has 4 teaspoons of flavor with 7 cups of water. And there's actually going to be two ways we can prove that one of these mixes is more flavorful than the other. So what I'm going to do is I'm going to rewrite my ratios. So we have our 2 teaspoons of water and our 3 cups of, our 2 teaspoons of flavor and our 3 cups of water. And we're comparing that to our 4 teaspoons of flavor and 7 cups of water. Now, what I'll be doing is actually comparing the amount of water that we have for each of these mixes. Now, both of these values are different, so it's going to be difficult to compare these values to one another. But what I can do is find a common multiple between these values in order to make the comparison a little bit easier. So you can kind of think of this as finding a common denominator when you're adding two fractions. So between 3 and 7, what I can do is multiply these by one another, and that'll actually give me my least common multiple. So 3 times 7 gives me 21. And I'm also going to be multiplying 2 times 7. Let me move this over a little bit. I'm also going to be multiplying 2 times 7 because I want to keep my ratios proportional to one another. So now we would hypothetically say if we use 21 cups of water, we would need 14 teaspoons of flavoring to keep the flavor the same. Similarly, we're going to be multiplying 7 times 3 by this ratio to get a value of 21 for our cups of water, and multiplying 4 times 3, because we want to keep our values proportional, and getting 12 teaspoons of flavoring. Now here, we can actually see that mix A is going to be more flavorful. And the reason why is because both of these mixes have the same amount of water now. We're both assuming that we're using 21 cups. But mix A is actually going to have 2 more teaspoons. It'll have 14 teaspoons in total of the iced tea flavoring. Now there is another way that you could solve this problem without finding a similar amount of cups of water. And what you can do is actually use the same ratios. Oops. You can use these same ratios. And instead of finding a similar amount of cups of water, we can actually find a similar amount of teaspoons of flavoring. And a common multiple between 2 and 4 is just going to be 4. So 2 times 2 will give me a new ratio of 4 to 6. And this value over here, I really don't have to multiply by anything, but I'm going to say that I multiplied by a factor of 1. So I have 4 to 7. And you're going to see that mix A is still more flavorful even though we showed different work. Now, some people might say that mix A is not the most flavorful because the values in this ratio are actually higher. But if you look closely, you should remember that our first value was the amount of teaspoons of flavoring, and our second was the amount of water. Now, while these both have 4 teaspoons of flavor, mix A actually has less water, so the flavor is less watered down compared to mix B. Now we're going to use another comparison, and we're actually going to compare two people running. So we're going to compare, I should say runners, not drivers. So we're going to be comparing these two people and seeing who is the fastest as they run. So Fry and Leela are racing one another. Fry was able to run for 2 hours. So I'm going to make a line just to show that we can solve this two different ways. Fry ran 2 hours and covered 15 miles. And Leela did the same thing, but she ran for 5 hours and covered 60 miles. Now I'm going to make a comparison between the value of miles, and I'm going to show you a little trick that you can use if you don't see a common multiple right away. So I'm going to list both of these numbers down here, and I'm going to list their first few common multiples. So let's just go up to 5 for both of these. 15 times 1 is 15, times 2 is 30, times 3 is 45, times 4 is 60, times 5 is 75. And I'm going to have 60, 120, 180, 240, 300. And I really didn't even have to use all those multiples because I can see that 60 is the first common multiple between both of these values. So for Leela's ratio, I really don't have to change anything. I can keep it 5 to 60 and maybe just say I multiplied by a factor of 1. But for Fry, I know that I had to multiply 15 by 1, 2, 3, 4. So 15 times 4 is going to give me 60. 2 times 4 is going to give me 8. So now let's say hypothetically that Fry and Leela had to run 60 miles each. It actually took Fry longer to run those miles. So I would say that Leela is the faster runner. Now again, you can solve these two different ways. So we're going to be using the same ratios of 2 to 15 and 5 to 60. But instead of having the same number of miles, we're going to use the same number of hours. And if you look at these two values of 2 and 5, I can see there's a common multiple of 10 between the both of them. 2 times 5 is 10. 5 times 2 is 10. 60 times 2 is going to give me 120. And 15 times 5 is going to be 75. So I can see if they were both given 10 hours to run, Fry would cover less mileage while Leela would cover far more with 120. So again, even though we solve these two different ways, we still get that Leela is the faster runner. Now I do want to mention that you don't have to do the same problem twice. If you happen to see that 2 and 5 is a much easier multiple to find compared to 15 and 20, you can change it to 2 and 5. Or I should say you can compare 2 and 5. You don't have to do these both ways. Now, I want to talk about what if we had fractions in our ratios. Now, many students are worried when they see fractions and ratios, but you can actually use this method over here to help you solve for a common multiple. So let's go to the problem. So we have two drivers, Stephen and Seth, and we want to see who's the faster driver. So again, I'm going to solve this two different ways. And as you can see over here, each one of these values is not a whole number. So we're going to have to get used to that. So for Stephen, I knew that he spent a quarter hour driving 1.5 miles. Oops. And then for Seth, I'm going to separate these. He drove for 2/3 of an hour and only covered 3/4 of a mile. So remember, our first value is hours. Our second value is miles. Hours and miles. So the first thing I'm going to be doing is comparing the number of miles to one another. Now, finding a common multiple between 1/2 and 3/4 might seem daunting, but what we can actually do is we can list the multiples of 1.5 and 3/4. So I'm going to do that right below here. So 3/4 and 1/2. The first multiple of 3/4 would be 6/4, which is equal to 1.5. And then 9/4, which is equal to 2.25. And then we can add another fourth, or I should say another 3/4, to get 12/4, which would just be a whole value of 3. Now, when I use 1.5, I have 1.5, 3.0, 4.5, 6, and I really didn't even have to go that far because I can see that 1.5 is the first common multiple. So I can leave my first ratio alone because the number of miles is already 1.5. So all we did was multiply by a factor of 1. And here we can see that we multiplied by a factor of 2. 3/4 times 2 gives me 1.5. 2/3 times 2 is the same thing as saying 4/3, or 1.33. Now both drivers drove 1.5 miles. Stephen took 1/4 of an hour, and Seth took 1 1/3 of an hour. So I can see already that Stephen is a much faster driver. Now we're going to show another method to solve this problem by doing what we've done before. So we're going to be rewriting the same ratios. But instead of comparing the same number of miles, we're going to be doing this to the number of hours. So 1/4 and 2/3 are going to have quite a few multiples until we get to the actual common multiple. So let's start with 1/4. We move from 1/4, and then we also have 2/3 down here. So we go from 1/4, 2/4, 3/4, 4/4, which is equal to 1. We have 5/4, 6/4, 7/4, and 8/4, which is equal to 2. And we're going to do the same thing with 2/3. So we have 2/3, 4/3, we have 6/3, which is equal to 2. So automatically I can see my multiple between these two is going to be a value of 2. So both drivers have driven for 2 hours. This one only has to be multiplied by a factor of 3. So 3/4 times 3 is going to be 9/4, or you could also say that that's 2.25. While this driver over here increased his rate by a factor of 8, and 1.5 times 8 is going to give me 12. So I'm comparing the 2 hours to 12 miles versus 2 hours to 2.25 miles. So again, I see that Stephen is a much faster driver, even though we found different common multiples. Now that you've completed the detailed notes, be sure to complete the retake activity. And if you would like to retake a test, be sure to reach out to me via Power Learning or my email, and we'll be sure to schedule an appointment for you to retake your test. Thank you.